Yesterday, we went one step further with something we had been doing before the break, and that was our Group B equations, our acceleration equations. Yesterday, we took a look specifically at acceleration due to gravity. We established yesterday with a little demonstration that all objects in the absence of air resistance will fall at the same rate. You drop a piece of paper that's crumpled up, and it will fall effectively at the same rate as a set of keys. Even though they have dramatically different masses, again, in the absence of air resistance, they're going to hit the ground at the same time. We saw a video yesterday where an astronaut on the moon dropped a hammer and dropped a feather, and they both fell at the same rate, albeit a slower rate than they do on Earth because the moon is a lot less massive, but still at the same rate as each other. Objects that are dropped in the absence of air resistance will always fall at the same rate. That rate on Earth, depending upon where you are, it varies a little bit, but that rate of acceleration on Earth is about negative 9.81 meters per second squared. Can anybody explain to me, please, why we put the negative in front of it? For an object falling, why is it negative 9.81 as opposed to positive 9.81? Okay, do you look like you have an answer to that? Why is it negative 9.81 instead of positive 9.81? Yeah, it's moving downward, and we make downward negative, typically at least, right? Downward is negative. If the object is speeding up in the negative direction, we're going to make it a negative acceleration. And that's what happens when you drop the keys or the piece of paper or the feather or the hammer. It accelerates downward, a negative acceleration. The problem is when I throw the object up into the air, the keys, the piece of paper, whatever, when I throw it up into the air, we also say the acceleration is negative 9.81 as it moves upward. Can anybody explain that one to me? How can it be negative 9.81 as it moves upward, but yet negative 9.81 as it accelerates downward as well? Yep. Good. If it speeds up in the negative direction, that's a negative A. If it slows down in the positive direction, that's also a negative acceleration. Somebody yesterday, I can't remember who it was, commented that it has to do with force, right? If you have a force that's acting downward, which is gravity, right? Okay, regardless of whether it's causing the object to speed up going down or slow down as it goes up, it's a downward force, so therefore the acceleration would be negative, downward in the same direction as the force. All right, so we've got our acceleration now. We're going to assume that's the value everywhere on Earth, although it does vary a little bit. Now all we have to do is solve some problems. Well, they're all Group B problems because they all involve acceleration. So we go back to those Group B equations. V is equal to VIT plus 1 half AT squared, and so on. And we solve our problem the same way as we did before the break, except now one more given. A is equal to negative 9.81. All right, we had 3 questions for homework last night, 1, 2, and 3 on page 58. Any issues, please, with any of those 3 questions? Yep, 3. Any others? 1 or 2? Okay, I'm glad you asked for number 3 because it's a little bit different, right? This one says an elevator moving downward at 4 meters per second experiences an upward acceleration of 2.0 meters per second squared for 1.8 seconds. What's its velocity at the end of the acceleration and how far has it traveled? This is not a straight gravity problem. Okay, objects that fall under the influence of just gravity will accelerate downward at 9.81. They give me the acceleration of this elevator to be a positive 2.0 meters per second squared, an upward acceleration of 2. Can anybody explain to me what must be happening for this acceleration to not be 9.81? Didn't I just say a minute ago that everything that falls has an acceleration of negative 9.81? But this elevator doesn't? What must be happening? What else must we have besides gravity? There's something else acting on this elevator, right? Otherwise, it would fall at 9.81. That's not an elevator you'd want to be in if it was falling at 9.81. Okay, because you'd have a pretty high rate of acceleration or deceleration when you hit the ground. This is being pulled upwards by a cable, by an elevator cable, right? So although gravity is pulling it down, the cable is pulling it up. Combined, they give me an acceleration of 2 meters per second squared. We're going to say for question number 3, VI is negative 4.00 meters per second. Up is positive, right? As it almost always is. We're going to say the acceleration here is not neg 9.81 because there is something else acting besides gravity. It is 2 or negative 2? 2 or neg 2? An upward acceleration of 2. Is that positive or negative? Anything upward is positive, right? Positive 2. How can it be accelerating upward yet moving downward? What's happening to this elevator? How can it be moving up and down at the same time? Is it? No? Were you kind of shaking your head no? Okay, so what's going on with this elevator, somebody? How can it have an upward acceleration yet be moving downward? Okay? Good. Just because it has an upward acceleration doesn't mean it's moving upwards. It's moving downwards. We're told that it's moving downwards, right? But the upward acceleration just means that something's pushing it up. Not hard enough to make it go up, but hard enough to make it slow down as it continues to go down. Okay, John, can you stand up for a second? Just come on up here. Okay, John is going to be moving to the right. Okay, just walk towards me. John's moving to the right of the room here, to your right. Okay, walk towards me. I'm pushing him to the left. Keep walking. I'm pushing him to the left. Not very hard. Keep walking. But not very hard. He's slowing down as he goes to the right. But the acceleration is to the left because the force acting on him is to the left. Does that make sense? Okay, just because I'm pushing him to the left doesn't mean he's going to the left. He may be still moving to the right. He's just slowing down. Okay, that's what's happening here, except we're dealing with up and down. Our time is 1.80 seconds. We want to find the velocity at the end of it, Vf, and we want to find the displacement, delta D, here. Do we have to find this? Do we have to find Vf first, or could we find delta D first? Does it matter what order we find these in? Who cares? Look, you're asked for two things. You need to find both of them. Who cares what order you do it in? Okay, the first thing that struck me when I saw this question is actually delta D. I said D is equal to VIT plus 1/2 AT squared. I don't know if that's the best way to do it. I don't care. All I care is that that's a valid equation, and I think it's going to get me delta D, which I want. Make sure you make that a -4, because it's downward. Make sure you make that a positive 2. And make sure you square the 1.8, which is a pretty common mistake to forget to square that. Okay, now let's get our calculator out here and let's solve for this. Let's say -4 times 1.8. Okay, that gives me -7.2. Let's add to that and use some brackets here. 0.5 times 2 times 1.8. Almost forgot to square that. 1.8 squared. Make sure you can get this yourself, okay? We end up getting -3.96. Oh, negative. It shouldn't be negative, should it? What does that mean? Spencer, what does a negative mean there? Yeah, of course it should be a negative. The elevator is going downwards. Of course the displacement should be downwards if it's moving downwards. So this is entirely reasonable, okay? They say, how far has it traveled? 3.96. That's correct. We didn't find the distance that it traveled. We found the displacement. So it's gone 3.96. Its displacement is -3.96. I don't care which one you put. 3.96, -3.96, either one's fine. Okay, we want to find Vf now. We've got a couple of options here. The thing that struck me is this one. Vf squared is equal to Vi squared plus 2AD. I have D now, so I can use that. Vf is the square root of Vi squared. That's 4.0 squared. Hey, why did I drop the negative there? That's a good question. That's a good question. Why did I drop that negative? Joe? Yeah, I was given initial velocity. I only needed initial speed in that equation, right? So I don't want the direction. I don't want the fact that it's negative. I don't care. The acceleration was 2, and the displacement was neg 3.96. Don't forget the negative there. Okay, this is a vector, so we have to put the negative on that one. Okay, let's solve for this one now on our calculator. Let's say 4 squared. Let's add to that, do some brackets, 2 times 2 times neg 3.96 and the bracket. I get 0.16. Let's square root that. And I get 0.4. Is that the answer? It is. Oh, here's another good question. It says down. I got a positive. What's wrong with me? Is there anything wrong here? What have I just found? Terry, you're kind of shaking your head no. What have I just found? Right, I found final speed. What was I looking for? Final velocity. How am I going to get the direction? Give it some thought. If it's moving downward, okay, if it's accelerating upward because it's moving downward, then what's our final velocity, up or down? Down, right? If our speed is 4.00 or 0.400, our velocity final is negative 0.400, or you can say 4.400 down. Either one works. How many people got that question, first part of it and the second part? Okay, kind of. Is that okay though? For those of you who didn't get it? All right, let's take a look at another one here. Oh my goodness, more questions? Oh, less than half of you got that one, so I think we need to do more questions, yeah. This one says a clown throws a ball upward at 10 meters per second. And the maximum height the ball goes. Oh, goodness. It's a good thing we are doing another question because this one looks hard. Here's one where we have to read between the lines. What do we have given to us here? Well, the clown is throwing a ball initially upwards at 10 meters per second. He's throwing it upwards, so we'll make the initial velocity positive, positive 10. That's all we have, isn't it? What else? There's something else, and everybody better get this right now. There's a couple other things, but the first one, everybody has to be able to get here. What else do we have given to us here, if we read between the lines? Good. The acceleration is neg 9.81, right? Even though it's going upwards, it's accelerating downwards because it's slowing down. So we're going to make a negative 9.81 meters per second squared. Now here's the tough one. Still reading between the lines, there is one more given to us. What is it? What else do we have here if we stop and think about this question? When it reaches its maximum height, that's what we're trying to find, right? Its max height. When it reaches its maximum height, what do we know? Yep. That it stops. Good. Just for a moment, just for an instant. But that's all we need. Okay, the final velocity as it goes up into the air is 0 because it stops. Now we're looking for the displacement. We're looking for how far it goes up before it stops, before VF is 0. I'm probably going to use this equation. It's a group B equation, right? VF squared is equal to VI squared plus 2AD. Let's just cross off VF. You know what? Let's not yet. We could, if you want to, but let's not. Let's rearrange this to solve for D. Let's get rid of what's not attached first. That's the VI squared. It's added to it, right? It's not attached. So it becomes VF squared minus VI squared equals 2AD. Now let's get rid of what is attached, the 2 and the A. VF squared minus VI squared. How do I get rid of the 2A? It's multiplied by d. What am I going to do? Let's divide it, right? Okay, now it's just a matter of plugging numbers into the equation here, okay? I'd say 0 squared minus 10 squared over 2 times neg 9.81. So how high does this go? Let's see. 0 squared minus 10 squared. Let's press equals. And then let's divide that by some brackets. 2 times neg 9.81. .09 or 5.10. 5.097 actually. There's my max height. There's how high it is when the velocity becomes 0, when VF is 0. The time that it takes to do so, this is easy now, the time that it takes to do so. Let's just say A is equal to delta V over delta T. We're just going to swap places here. T is equal to delta V over A. VF minus VI, 0 minus 10 over neg 9.81. I get neg 10 divided by, neg 10 divided by neg 9.81. That's a time, try that again. Neg 10 divided by neg 9.81 gives me 1.02 seconds. 1.019 seconds. More of the same, but an extra little dimension here where we had to notice that the final speed was 0 meters per second. Okay, we weren't told that. So two things we had to notice here. Acceleration, neg 9.81, VF, 0 meters per second. All right, let's take a look at one simple, or I should say, not say simple, one single practice problem that goes along with that example. Page 59, please. Let's see what you can do with that for the next, let's say 5 minutes or so, and then we'll check it over as a class. All right, let's take a look at practice problem number 1 here on 59 here. It says, the slingshot drops riders 27 meters from rest before slowing them down to a stop. How fast are they moving before they start slowing down? So it's kind of, it goes kind of like this. This used to be a ride at West Edmonton Mall. It's not there anymore. They have a different ride. But I always liked this one better. It was called the Drop of Doom back when they had it. It went like this. They took you up in this this kind of enclosed cart, although it was enclosed with this metal grate that you could see through, including the floor. You'd be pulled up this rail to the top, and then you'd be pushed out to here, to this rail, and then you'd literally free fall straight down for about 30 meters, literally straight down, and then go around the rail like this, and then slow down and stop. So that's what we've got going here. This is what we're concerning ourselves with here, right? The drop. Okay, it's free falling, okay, 27 meters before it begins to slow down and come to a stop right here. How fast are they moving before they start slowing down? In other words, how fast are we moving right here? What's VF right here? VI, what do you think VI is up here? How fast are you moving when you start this ride, start this fall? Yeah, they don't throw you down. They just drop you. So you're moving at 0. We know the displacement here is going to be negative 27 meters. And we know the acceleration is going to be negative 9.81 meters per second squared. Let's use this one. VF squared is equal to VI squared plus 2AD. VF is an easy one to find. It's the square root of this. VI is 0 because it starts at rest. This is especially easy to rearrange, at least. Becomes the square root of 2 times neg 9.81 because that's the rate at which it accelerates. D is neg 27. And do all that math, it works out to be positive 23 meters per second. Doesn't the positive mean it's going up? Tara, I think it was Tara that kind of addressed this earlier in a previous question, in an earlier question, that we haven't actually found final velocity here at all, right? We found final speed, right? So of course we're going to get a positive number. It's speed. That doesn't mean up or down. It's just speed. We know it's moving down. So if we were looking for the velocity, we could just add the word down there or add a negative to it. Okay, we know it's going down. But in the end, we're not looking for the velocity. We're just looking at how fast it's moving. So we're looking for final speed 23. Good? Let's take a look at one more, okay? Isn't this the same question? A clown throws the ball up into the air at 10 meters per second. Find the time that it takes the ball to return to the clown's hand for maximum height and the ball's final velocity. It's not the same question. Remember the last example here said we want to know the max height. This one says what's the time that it takes to go down from the max height and what's the ball's final velocity. Let's answer B first. Because B, if you're thinking about this, you can use a little bit of logic on this one. If I throw something upwards at 10, it slows down at 9.81. It slows down, slows down, slows down, slows down, slows down, stops. And then it speeds up at the same rate as it slowed down. How fast is it going to be moving when it goes past that point where it started? Austin? We'll kick you ready to give me an answer there. No. It's 10. If it starts at 10 and it slows down to 0 and then speeds up again, but speeds up at the same rate as it slows down, then it's got to be moving the same speed as it started at, right? So the final velocity here must be negative 10 meters per second. Same speed, opposite direction. The time that it takes the ball to return to the clown's hand for maximum height. Let's go to do A here now. We know that A is neg 9.81. As it falls, VI is 0. What else do we know? We know the displacement as well, right? The displacement came from the last question. What was it? 5.097 meters. Or negative 5.097 because it's falling now. Anything else we have there? Oh, wait. We could do this. We pretty much have the answer. If it took 1.019 seconds to slow down to stop, how long is it going to take to speed up back to 10 meters per second? 1.019 seconds. Let's say you didn't notice that, though. Okay, let's say you didn't catch that. How do we do it then? Let's say D is equal to VIT plus 1/2 AT squared. On the trip down, VI is 0. Solving for T here. The 1/2 A is multiplied by T squared, so let's divide it to get it to the other side. Want to get T by itself? Let's square root it. We're going to say negative 5.097 divided by 1/2 of neg 9.81. Let's go root that. And lo and behold, we are going to end up with 1.019 seconds. How many people would prefer to do it the logic way? You just notice what it is, right? Based on the previous question, based on the symmetry of going up and down. How many people would prefer to do it the math way? Okay, whatever. I mean, whatever works for you, right? They're both right. Okay, whatever works for you. One more problem. That's all you're going to have to do today. That's your homework for tonight. Practice problem on page 60. Right now, guys, I'm going to tell you that, what's today, Tuesday? I'm going to tell you for Thursday, you're going to have some check and reflect questions, okay? So I'm going to tell you about them right now. That way, if you're busy Wednesday night, you can have a look at them tonight and maybe get them done ahead of time. For tomorrow, we have this problem due, page 60. For Thursday, we have page 63, number 2 to 16. Say Wednesday? This is for Friday then. Sorry, I get my days mixed up. Okay, that's for Friday then, 2 days. Okay, this is for Thursday.